Hello and welcome to this, my home away from home, the MHT dome of the University of Lancashire's Alston Observatory. Now a few days ago I posted a video which described some of the interesting properties of the third interstellar object we've ever discovered, 3I Atlas. In the intervening time, 3I Atlas has actually made its closest approach to the inner solar system, its closest approach to the sun, and is now beginning to move out of the solar system again. Now, because that closest approach occurred coincidentally when the Earth and the Sun were aligned such that 3I Atlas was hidden from view from the Earth, from telescopes like this one, there was a lot of speculation that we would not be able to see this most interesting point in a comet's journey through the inner solar system, the point when it's closest to the sun and it's therefore heated up the most and is the most active. But fortunately, we don't have to rely on telescopes on Earth, because in space we currently have a flotilla of different space missions up there, many of which have been turned to observe 3I Atlas. And in the last few days, some interesting results have started to come out from those observations. So I thought I would do a continuation video where I bring us up to date on these really interesting and new discoveries, and also I hope put to bed some of the more ill-informed commentary that's been going on, which seems to think that anything interesting about this comet must be signs that aliens are involved. Sometimes a comet is just a comet. And so in this short video, hopefully we'll go over that and you'll come away convinced that this is an interesting comet, but still a comet. Now, the first observation that people have got quite excited about has been the observation that 3I Atlas brightened quite considerably and quite rapidly as it approached the sun. This object is moving much, much faster than any other comet. That's what means it is actually unbound to our solar system and will eventually leave our star system. So because 3I Atlas is moving so rapidly compared to other solar system comets, it's entering the inner solar system much faster. And that means it's approaching the sun much more quickly, and therefore it's heating up much more rapidly than any solar system comet would usually do. And as a result, more and more of the volatile material that make up the bulk of the comet, of things like water, carbon dioxide, carbon monoxide, more and more of that is sublimating. It's turning directly from solid into a gas and then building up the coma of the comet. And it's the coma building up, becoming denser and larger, and therefore reflecting more light, that is actually causing the comet to brighten so significantly. Now, the plot on the screen shows you the behavior of the brightening of the comet, and what you can see is it's actually fit extremely well by a model where there is essentially two phases. When it's further out in the solar system, most of the coma material is in the form of dust, and then later on, as it approaches the sun, there's more and more of the light is being reflected by gaseous material. And I just want to be clear about this. This is actually being fit there by models that are, designed or were constructed to fit solar system comets. And this thing is being fit perfectly well by models that model the behavior of solar system comets. So there's nothing out of the ordinary about how this thing is brightening, except that it's moving very quickly and it's therefore brightening relatively fast. I also want to point out that the peak brightness there is about 9th magnitude, and even by the end of the month, when this thing becomes easily visible further away from the sun, that will still mean that it's still relatively bright and actually easily within reach of any amateur telescope. So it's just the kind of thing that you might want to try and observe yourselves. Now, the second observation that everyone got excited about is the observation that the comet has been observed to change colour. So when 3I Atlas was first picked up, it was noted, and you can see in the pictures, that it was quite red in colour. Not redder than anything we've ever seen before, but still quite red. Now, why does that matter? Well, remember that comets mostly just shine by reflecting sunlight. And what happens is that that sunlight that hits the comet and then bounces back, it will not reflect 100%. It will be absorbed at certain wavelengths preferentially. And in particular, for this comet, it was releasing quite a lot of dust. And space dust, cosmic dust, essentially, like most dust, preferentially absorbs blue light. It will tend to let red light pass through, but it will absorb and scatter and reflect blue light. And what that means is, although you started off with a sun-like spectrum, when that hits the comet, preferentially you lose the blue light, and the light that gets reflected back is redder than it would otherwise be. So the comet will appear redder than the solar spectrum. Now what's happened here is a bit unusual in that the comet has actually turned bluer than the solar spectrum. Now we have to be a little bit careful because we're reacting here to things that have been posted on social media. There haven't actually been any papers released detailing the exact amount of light that is being reflected. But nevertheless, the claims made are that the comet is now bluer than the solar spectrum. And obviously that should, or appears, like it would cause a problem, because if it's just reflecting light, then it should either modify the spectrum and preferentially absorb blue light, in which case it will appear redder, or it should effectively reflect the sunlight perfectly and it will look like the solar spectrum. It's actually essentially physically impossible to come up with a sort of dust combination that will preferentially get rid of red light and leave blue light behind. So the fact that it's bluer than the sun is telling you probably that there is some additional blue light that's being given out by the comet. So I have a theory that essentially there's two different things going on. The first is just that as the comet has approached the sun, it's heated up and more water vapor and water ice has been released. And as that has been released, it's essentially compensating for the dust that's present, and it is reflecting more of the blue light. So the spectrum over time has probably shifted towards the bluer end anyway, so that it will become closer to the solar spectrum. Not quite as blue as the solar spectrum, but closer to it. And then on top of that, there's this strange phenomenon which had been seen before in a solar system comet called C2016R2, in which there were CO, so carbon monoxide molecules, being released by that comet. And we know that the CO being released by 3I Atlas as well. And that CO, and along with a little bit of nitrogen, when it got out into the coma, it was being ionized by the ultraviolet light of the sun. And one of the things that those molecules would then do would be to recombine and would be to react, and that would lead to a release of blue photons. So spectroscopy of C2016R2 clearly showed that most of this blue light was coming from the emission of narrow emission lines from carbon monoxide. We haven't been able to measure such things in 3I Atlas yet because it's still hidden behind the sun, but I expect potentially that when those observations are made over the next few days as it continues to move from behind the sun, we might well expect to see some carbon monoxide or nitrogen or some other molecules which lead to emission lines in the blue. And so the addition of that extra blue light, which is effectively reprocessed ultraviolet light, with the now closer white light spectrum caused by the ice reflecting the light, I suspect the sum of those two will give you this spectrum which is now bluer than the sun. But we will have to wait and see. The third observation that everyone got excited about was that 3I Atlas is now finally observed to have some non-gravitational acceleration. So just to remind you, non-gravitational acceleration is an acceleration where you are moving with some essentially thrust. So prior to its closest approach to the sun, 3i Atlas had been observed for quite a long time by a lot of different telescopes, and we had a pretty good orbit estimated for it. And the observation showed that the object was moving with exactly the path you would expect given its initial velocity, its initial direction, and the gravity of the sun. As it's approached the sun, it has now had measurable non-gravitational acceleration. And that is simply due to the fact that this is in fact a comet. And as it gets closer to the sun, it heats up and it releases gas. And if that gas is preferentially released in one direction or the other, it will provide a thrust. And that will begin to push the comet slightly out of the orbit that was originally calculated for it. And so in this case, it has a very small but measurable non-gravitational acceleration. It's something like 0.02 millimeters per second that is changing its velocity at. That is not enough to cause it to move its orbit appreciably. It won't get any closer to any of the planets by any significant amount. And why I bring that up, of course, is that the apparent non-gravitational acceleration or lack of non-gravitational acceleration was itself a point of contention and a claim that it must be somehow alien technology because it was observed to have cometary outbursts, but it wasn't observed to have non-gravitational acceleration. Well, it does now, and it's behaving exactly like a comet should. And figuring out the orbit and any changes in the orbit of 3i Atlas is, of course, interesting from a scientific point of view because it does tell you about something about how much gas is coming off and any preferred direction. It's also interesting here because, of course, of the conflicting and changing claims that have been made about this regarding, supposed alien nature. If you recall back when Avi Loeb was first describing his reasons why he thought this thing might be alien technology, the original claim was that its orbit had been chosen so that it could fly behind the sun and make some sort of slowing maneuver to allow it to swing back towards the Earth while it wasn't observed. I would agree. If that object had done that, there's no doubt that thing would have been an alien craft. However, it didn't do that. And in fact, in the run-up to the point where it was going behind the sun, Loeb himself changed his argument, probably because he was aware nothing was going to happen. And his argument shifted to be that if it didn't do anything, if it just flew out through the solar system unchanged, that would be proof that it was aliens because it would actually be a big mothership and it would just be releasing little spacecraft that we can't see. So if you're keeping track, if it changed orbit for Loeb, that would be proof of aliens. Actually, it would be proof of aliens for everyone. But if it didn't change orbit, that would also be proof that it was aliens for Avi. So talk about having your cake and eating it there. And one other reason why we're interested in the non-gravitational acceleration of the Comet 3i Atlas is, of course, because it can tell you something about the mass of the object. So another one of Avi Loeb's arguments as to why this thing must be alien was that he had made an estimate of the mass of the object. And the way he did that was to use an upper limit on the non-gravitational acceleration and say, well, given that it's releasing some material, it must be very massive if that material isn't enough to provide enough thrust for us to measure it. Now, other people far more qualified than me have pointed out that he made a couple of really big howlers in that estimate. And in fact, the mass that he came to was potentially as big as 1,000 or 10,000 times too high. So now that we have a more robust measurement and we can apply some of the actual correct approaches to estimating the amount of non-gravitational acceleration and the mass of the object, we will or should be able to get a better estimate of just how heavy this thing is. And that'll be interesting because we are interested in what is the distribution of masses of these interstellar objects. They shouldn't just all appear sort of with different masses at equal probability. There should be a distribution. Now, whether or not that's a power law or a Gaussian or whatever, who knows at this point? But we'll be able to measure it, and then by measuring more and more of these things, get a better understanding of how their mass distribution, how it looks, and from that infer something about how they formed and also the processes that go on as they are wandering through interstellar space, just how much material is being removed from them, for example. So there you go. That's my overview of what we've learned about 3i Atlas in the last few days. As you can see, 3i Atlas remains a comet, a very interesting one, but a comet still the same. So I hope you enjoyed this video, and you'll consider liking and subscribing to see more videos on similar topics. And if you have any interesting comments or burning questions, feel free to leave them below, and I will attempt to get to them when I can. Thanks.